Hello friends, welcome to Joy of Life. So in the last video, we have talked about the coding interview for a software engineer and senior software engineer. And in this video, we are going to talk about the system design interview for software engineer and senior software engineer, right? So for a senior software engineer, the expectation and the number of rounds will be more, definitely. And for software engineer, it will be comparatively lesser. You might have one or two rounds based on your years of experience and the kind of experience that you have. If your experience falls between 0 to 3 years, you might not have a round as well. But if you have more than 3 years of experience, you'll definitely have a round on system design interview. But if you have 7 or 8 years of experience, then the expectation from system design interview is going to be pretty higher. So you fall in the bracket of senior software engineer. If you are more than 10 years, it will be in the senior software engineer 2. For senior software engineer 2, the expectation would be really high. You need to have a great understanding of the overall architecture of how all the components work, their internals. And what I have done, we are going to talk about all these things in a lot of details. What I have done over here is I have captured the preparation part and the execution part, just like the last video, and we are going to understand each one of the topic. We are going to break it down in details. We are going to capture some do's and don'ts in the board, and we are going to understand how you should prepare yourself for the interview and how you should face the interview. So with that, let's start the video and understand all these points in a lot more details. So we are going to start with the preparation part first. And in the preparation, we are going to look at what all to prepare. I will show you some resources. I will show you the techniques on how to find out the resources, what all to be prepared, and how to prepare. So to start with, we have two important points over here. Understand the system design basics. So you need to understand all the components that we use in day-to-day life for designing systems and their internals and how they work. You should be well versed with them. So here I am at educative.io, and this is one of the course that I'm going to recommend highly. This is a personal favorite of mine, Rocking the System Design Interview. So this is pretty detailed, and it's going to give you a very good understanding of how to prepare, what all to prepare, and how to approach the interview question even. So if you go to the course overview, you will see that you have system design problems, wherein they have discussed problems like Pastebin, Instagram, Dropbox, Facebook, Twitter, most of the service we use in our day-to-day life, and they are pretty detailed. So it's highly recommended that you go through all of them. And if you scroll down, you will find in the section 2, you have the glossary of system design basics, wherein you have all the components and all the important things like load balancing, caching, data partitioning, indexes, proxies. The list is long, and I am not going to go through all of them in this video, but I want to tell you what all to be prepared. So I'll pick up a few examples from here, and we are going to discuss based on that. So here you will find the list of all the components and the system design basic concepts like cap theorem and all. So let's look at load balancing. So in general, we know when we get a huge load on our service, what we do is we distribute the load across multiple servers that we have. But that is not good enough. You need to be more detailed. You need to understand lot in details about what a load balancer is, what it is capable of. So I'll take you to a different site over here. So here I am at Simply Cable, wherein we have the load balancer example over here. So you can see over here that we have the client, we have the resources, and in between sits the load balancer, right? And the load balancer is capable of doing a lot of functionality. It should not be doing all of them. It might be between one to all of them. The primary thing is the workload distribution, right? And when we talk about distribution, there are several strategies, and you should know what are those strategies. Let's see what all it is also capable of doing. Like it can check your certificate, it could do request tracing, it can have scheduling algorithm, encryption, redirecting your requests, auto scaling, server name indication, fixed responses. So if you want to send a fixed response back, it is capable of doing that. It will keep the load out of the entire system. It can perform health check, authentication, rate limiting, sticky session, compression. So if you are getting a payload, it can compress the payload. It could act as a firewall. It can have persistent connection. It can do caching. It can do even monitoring and logging, right? And now if you start reading about all of them, you will get to know the bigger picture of what a load balancer is capable of. A load balancer can act in different layers as well. So as we scroll down this article, you will find more details about the same. So here is workload distribution, and there are several strategies: host-based, path-based, content-based. I am not going through all the details of everything over here. I am showing you how to uncover the things and what all to be prepared. So in this section, you can see that it can operate in multiple layer. It can be in network layer or it can be in application layer. So it is commonly known as layer 4 and this is known as layer 7. So you can check over here as well. It is mentioned. And then we have the scheduling algorithm. There can be several algorithms in which the load can be passed on to the servers, like round robin, weighted round robin, least connection, weighted least connection, adaptive load balancing, chain failover, response times. So you should understand that there are several ways the load can be distributed. There could be multiple load balancer even. It's not required that you will have only a single load balancer. So once you start reading about it, you will uncover a lot of details which you can check and you can scale your learning, and it would be a good help during your interview. So coming back to this list again, so let's pick up one more. Let's say the proxies. So for proxy also, I have the same site Simplicable over here. So there are multiple kinds of proxy. There could be a normal proxy, there could be a reverse proxy. So you should understand that what is a reverse proxy versus what is a normal proxy. Which one to choose based on the scenario that you have. So once you read about them, you will understand that what a proxy does and what is the role of a reverse proxy. So you can see here that it is shown with a detailed diagram so that you get a very good understanding along with all the descriptions. And also they have shared in a very nice way the definition, pattern, type, common implementations, common use cases. So I highly recommend you go through all this list over here, all the things listed over here, and you will have a very good understanding. Now coming to the caching part, caching could be of various types as well, right? We can cache the static media. For example, we want to cache the thumbnails. In that case, we use a CDN. We can cache some responses. In that case, we can use a normal cache like Redis or Memcache. You need to understand what is the TTL that you are going to use for your cache. What is the time to live? How do you invalidate the cache? How do you know your data is becoming stale? What is a write through cache? What is a write around cache? What is a write back cache? Your eviction policies. There are so many things that you should understand. When you say that you are choosing a cache, your selection or your choice has to be justified with proper justification, right? It's not out of random we choose something and start using it, right? So when we are choosing a cache and putting it in a particular area, we need to justify why do we need it, how much data we are going to cache, for how long we are going to cache. All those things should be covered in lot of details. So with that, we have covered the first 2 points over here. So we have talked about the basic components and their internals part. And now coming to the third point, microservices patterns. There are several patterns that you need to understand. So here I am at microservices.io. It is another very nice site which provides a lot of learning. Let's think of a scenario wherein you have a big monolith and you want to break the monolith and come up with microservices. So what are you basically trying to do is to break your services into multiple smaller services, right? Basically, you want to decompose your service, right? So how do you decompose it? So for that, you have several patterns in which you can decompose things by business capability, by subdomain. It can be self-contained or services per team. So these things over here, these blocks over here talks about different patterns that we are going to use in order to do things. For example, we have the infrastructure pattern wherein you have a circuit breaker. So let's say you have a bunch of services. So let's say you have this service over here. When it gets a request, it makes a call to this service. It makes a call to this service to get some data. It also makes a call to this service. This service in turn call this service, and this service in turn call these two services to get the data, and then sends it back, and you send the response back to the client. So let's say we see that this service over here is down, or it's consistently throwing a 500 error, some internal server error. So what we can do is over here we can have circuit breaker. So this will break the circuit over here. So what a circuit breaker does in a real life, right? It stops the flow, right? So that's what a circuit breaker also does in this case. So you need to understand where all you need to put a circuit breaker. And when we talk about circuit breaker, there could be a lot of things, right? So you can click on the box to read more about the circuit breaker. I think the CSS is not loaded. Yeah. So over here, you will get the context, you will get the problem, what it is trying to solve. So you can see here that it is trying to stop your cascading failure, right? You don't need to fail all of them. If you read about normal circuit breaker microservices, you can open any site from here. Let's say we go to Medium, and you will see that there are a lot to understand in a circuit breaker, right? There could be a lot of state, right? A closed state, a open state, a half open state, wherein I allow some of the requests to pass through when I see a problem before I completely close it down, right? So do go through all of them, try to understand what it does, right? And over here you can see that they have also given example, but these example are from Hystrix. There are Brazilian Forge Hystrix. There are a lot of frameworks which provide this kind of functionality. You can go and check them out, but before you go and check them out, the main intent over here is to understand how the circuit breaker works, where to put the circuit breaker, what is a circuit breaker. So all these things, so you should know what the functionality of a circuit breaker is, where to put it, what are the pros and cons, what are the different state. Everything should be well versed when you are choosing a solution, right? It might happen that you get some follow-up question when you talk about circuit breaker, load balancer, anything, right? And if you are not well prepared, the knowledge will look more bookish, or it will not look hands-on. So definitely hands-on is required. So go ahead, try to create a load balancer of your own, try to implement a circuit breaker. You might think that yeah, my project is not using circuit breaker, so how can I do a hands-on, right? So don't stop yourself, go ahead, just create a small Spring Boot application, try it out, try things out. So here I want to recommend one of the playlists that I have created, that I was working some time back, this mini system design, right? Wherein you can see that I have used almost everything, though I am not using them in my project. There is MySQL, there is Cassandra, there is Kafka, there is Zookeeper. So you can definitely go ahead, create a Docker container, play with it. You can have your local Kubernetes setup. Everything is thoroughly covered in this course. This course is completely hands-on, not theoretical course. So do go ahead, check out this video if you are familiar with Java or Spring Boot. And even if you are not, the technology cannot be a bottleneck for you, right? So you can check over here. I have tried using a lot of things, retrofit, many things that I have tried out over here, Redis, Cassandra, many things that I have tried. So when you're reading about something, go ahead, try it out. Once you have done the reading, go ahead and try it out yourselves. It will definitely give you a lot of understanding. So we just talked about circuit breaker from here. We talked about the decomposition from here, and I'm going to pick up something from here. Let's say API gateway. This is another very important and quite frequently used thing. So you should understand what a API gateway is, what it does, what are the capabilities of a API gateway, why do we need it, right? So along with API gateway, you can have the service discovery also in place. So go ahead, read out all these things, try it out yourself, try to implement them. Again, in my project, if you check that I have used Zool for the API gateway, so I have configured it myself. I have tried to have the server-side discovery in place. I got my share of the understanding. I created a video for you guys. This could be helpful. So go through this, go through it sequentially. I have discussed about what the project is all about, then made a lot of code and all that things. And then I have re-evaluated the mistakes that we have done in this, and we have corrected it as well. So over here you can see that looking back at the design choices made, evaluating Cassandra, Redis, Kafka, MySQL, that did I make the right choice or not? Few of the wrong choices that I have made initially was deliberate, and few of them was I was not aware of them. So I learned from it. I moved on. There is no harm in doing that, right? So do check out on all these materials that I am talking about over here. There are some really interesting patterns, and you'll be fascinated to know about it. Not only it will help you during your interview, but it will also make you a better architect or a senior engineer or whatever role you are playing, right? Again, microservices.io was not the only site. You can check out at design pattern for microservices from dzone. I'll share all the links over here. You'll find a lot of patterns over here: decomposition pattern, integration pattern. We have just talked about API gateway, so you can see that it's already here. Then you have database pattern. So how you should keep your databases, should it be shared or should it be for a particular service only? So you should have a good understanding about all these things. And another good read about microservices pattern and architecture is from medium.com, wherein I saw they have created a very nice table wherein they have captured somehow the image has not loaded. Let me do a refresh of the page. So here are all the patterns, and they have bucketed it by decomposition pattern, integration pattern, database pattern, observability pattern, cross-cutting concern pattern. So go ahead, read about them, watch some videos. Even I am planning to create some videos on few of the topics over here. So build a thorough knowledge about all of them. So the first 3 points were particularly based on those things only. Coming to the next point is about the deployment. So when you are talking about a deployment of a microservices, you will definitely have a complex deployment, right? So let's take an example over here in order to understand the same. So let's say we are building a site like Amazon where we have a microservice for the cart, one for billing, one for product, right? So maybe for cart, you need your 100 instances to be there, right? A lesson number for your billing, and your product is viewed more, so you want probably 500 deployments, right? So this basically means that you are having your cart service deployed into 500, 100 rather, different instances, right? Similarly, for billing, you are putting it into 50 different servers or containers, right? It's deployed like this. So you are already deploying a 600, 700 only for 3 services. There would be more services, right? And you have a minimum container, you have a maximum container. You have said that you need 100 as your minimum number of containers, and maximum it can go up to 500. For billing, again, you said it can go up to 500, but this is your minimum over here, and this is your maximum. And for this, you have said that, okay, it can go up to 10,000 because there are a lot of products that being viewed, right? Than being added to the cart or being built or purchased. So we are talking about a huge number of deployments over here. All these are my deployments here, right? So we need to keep a track, right? Maybe you have defined this minimum and maximum based on few parameters like request volume, how much request I am getting over here. Or what you have said that, okay, if my CPU performance, if my CPU usage is going about 80% or so, you scale, you have more number of instances, then it will start going up from 500 to 501, 502, and it will keep on increasing, right? So when you are deploying a microservices, it is very important to know that what are the limits, what are the type of instances that you are choosing, right? So over here, you are choosing some instances where it's being deployed, right? So you have to understand what are the capabilities of the system that you should choose. That should be backed by some numbers, right? Some performance tests, some load tests. You have to justify them. These request volume, the CPU usage, everything needs to be justified. So it plays a very important role over here to understand that how I am going to deploy my application, how I am going to manage my deployments. So there are solutions like Kubernetes that help you to achieve the same. So you just create a configuration, you will get a very thorough understanding about how this deployment works, right? So we have the lowest level as pods, and on top of pods we have replica set, we have services, then we have deployment. So if you talk about Kubernetes, this is with respect to Kubernetes. You should have an understanding how to get a pod, how to get the logs from the pod. So for a senior software engineer, it is very important to understand how this entire ecosystem works, right? And all these pods, they are emitting some logs, right? We have to monitor those logs, and from these logs we have to create some alerts so that we know that things are not working as expected. Some services are continuously going down, some APIs latency is not good enough, it is taking more time than expected. So these are all covered in your microservices deployment and management, right? How your service is going to be managed and deployed. So do spend some time in order to understand them. And now I'm going to show you something very interesting. The next point we have is how others are solving their complex design challenges. We have so many services that we use in India, especially we have services like Swiggy, Zomato, Uber, Netflix. Some of them are used worldwide, definitely, but some of them like Swiggy and all is local. So we need to know how they are solving such a problem. So you need to understand how Swiggy is enhancing their services, how Uber is coming up with the new strategies, right? So I'm going to show you something very interesting that you should do. So you can pick up any company that you like, let's say Uber, and you can search with their engineering blogs, and you will find, let me zoom in for you. You will find Uber engineering blogs, wherein you will find a lot of details about how they are solving their problems. So let's go ahead and check one of them. some problem, the CSS is not loading first time. Yeah. So you can see that how Uber migrated financial data from DynamoDB to DocStore. So looking at the first header, it strike me, I don't know what is a DocStore. Just go and find out what is a DocStore. You might think that, okay, I don't know what is a DynamoDB. It is the time you should go ahead and find out, right? DynamoDB is definitely an option for you then, right? It is a database, so you need to know what kind of database it is. Maybe you are not aware and it is something that is useful for your project. So go ahead and explore about the same. So you will find interesting reads over here, engineering reads, management reads. So if you are just looking for the engineering reads, find out the relevant topic, like the improving HDFS IO utilization for efficiency, how to do that, right? It might happen that you get a problem statement like this in your next assignment, right? It's good to know how others are doing it. These official blogs are written by the experts in the company, right? So definitely there is some good material that will definitely help you to know things and scale yourself up, right? So you can see a lot of categories over here about data, events, general engineering, so a lot of things, developers. So you can go to the section that you are interested in and you will definitely find some awesome read about different technologies. The architecture of Uber's API gateways. Few minutes back, we talked about the basics of API gateway. So once you get the basic, now go ahead and read about how this is being done, how the scaling of Uber's API gateway has been done. So these are all the good things that you will get to know, right? So when I talk about Uber and all, they have a huge number of requests coming in. So they try to do things in a very, very efficient way, right? So you should know how others are doing things. This will give you a lot of insights and lot of knowledge. So go ahead and check them out. I'm not going to discuss any of the things over here. I'm just showing you how to discover this material and how to leverage on that. So not only Uber, just go ahead, change the name to anybody and you will find their engineering blogs. So you have the bytes.swiggy.com. So you can go ahead and check their blog as well. Something's wrong with my CSS. Okay. So just go to the engineering part and read about the things that you find is interesting, right? So you'll find a lot of blogs over here about different thing, accessibility. There are content for the UI guys. There are content for the backend guys, right? So go ahead and read about them. You will find a lot of blogs over here. So here we are at the Amazon's blog over here. Just find out what is interesting, what you are looking for, cloud and systems you are looking for. Go ahead, check out what is interesting, what is relevant for you. Go and read about them. Adaptive load balancing for parallel GNN training. So now you have read about load balancing few minutes ago. Find out what is adaptive load balancing. So be an explorer, go find out things. You can pick up anybody. So you can just take a name, just put the name over here and you will definitely find a lot of interesting read about them. So this will give you a competitive edge over others in terms of interview as well as a day-to-day developer or an architect. So go ahead, read about them. So now that you know the secret of how to do things, so you are good now. So this is the part where we have taken care of our basics. And this is the part where we took care of our advanced needs. And do keep in mind, this is a continuous process. It's not a one-time thing that you will do and you will forget. This advanced part is changing every day. Even the system design basics, there are new things coming up every day. If you see here, when I purchased this course over here, we didn't have all these things. It was still here, till cap theorem. But you can see that you have new things coming up regularly, consistent hashing, quorum, Bloom filters. There are a lot of things that you need to read about. Gap theorem is something that you should be knowing in a lot of details. I would also be creating a video on these content as well. But I still highly recommend that you go ahead and take a subscription of this course and also read the engineering blogs. That's going to help you a lot. Now coming to the next part, how to practice for the interviews. So for coding, it was pretty simple that you write the code, you submit the code in lead code, and you get to know that you have passed or not. And not only that, you also get to know that where you stand compared to the other submissions. You're doing better than 80%, doing better than 90%. But for system design, it's not going to help. You are never going to find it out, right? Because there isn't any single answer. There could be multiple solutions that could still suffice, that could still be good, right? So you cannot prepare alone. And if you practice alone, you will always feel that your solution is correct. So what you need is a partner with whom you can practice it. So your partner will act as an interviewer and you will act as a candidate. You can reverse the role if he's preparing for interview as well. So basically the intent is the interviewer will give you a question. So you will have two person over here. So this is, let's say, your partner and this is you. This is your interviewer and this is you. He gives you a problem statement and you need to give him the solution. So you have to convince him. So when he's giving a problem, that means he has something in mind. He has thought about something and you are giving a solution which might not be in sync with his, right? It might not be in sync. So you are going to convince him that this solution is good enough to take care of the requirement, right? And he will come up with some questions, some follow-up questions, and you need to answer them and convince him to get the thing working, right? So if you can convince him, that means you have cleared up the interview, right? So practicing alone is never going to help you at all. So find a partner. It could be your friend, your colleague. It could be anybody who has the knowledge of system design, and practice along with him for the mock interviews. Just to add over here, I am also planning to start a mock interview session. If you are willing, I am going to start a series on my channel on mock system design interviews, so you can volunteer. So you can just drop a comment below and I'll definitely contact you for a mock interview, and definitely I'll be publishing that in the channel once you are comfortable with the same. Again, the main purpose of having this mock interview is to have the content for the others who are watching the interview and for you to grow. So there is nothing to feel bad. I'll be doing a hand holding to scale you up to the level depending on how you're approaching the problem. So I'll be showing you the ways that you should approach the problem. The main problem comes how to organize the interview. So we are going to see that in the execution section, and with that what we'll do is we are done with the practice for the interview part. So you'll need to pair up with a partner or you can pair up with me for my channel, and we can get that done as well. So with that, let's conclude with the do's and don'ts for the preparation section. So here are some do's and don'ts that I want to capture at the end of the preparation section. So the first one is reading about engineering blogs from other reputed companies. So once you have built up your fundamentals using the first three steps over here, do read a lot of engineering blogs, keep yourself updated and prepare well before going for the mock interview. So even if you are going for a mock interview, don't take it lightly, take it seriously, make it time based, make it like a proper interview. I am going to talk about the interview format in a bit in the execution section, but make it look like a real interview. Don't just do it for fun. And definitely don't do the mock interview alone, do it with a friend or a partner. So doing alone again is not going to help you. You are always going to feel you are doing the right thing until and unless somebody challenges you on some part of it. Do watch out some videos. That's also I'll recommend that there are a lot of interview videos that you can find on the web. Check them out from your favorite content creator if you want. And we'll also be having our own mock interview soon, so do check it out on the same as well, and definitely let me know if you're interested. So with that, we are done with the preparation part, and let's move over to the execution part. So coming to the execution part, the first thing, you will meet a stranger once again from the other team, and here you have your 60 minutes for your interview, right? So the first 5 to 10 minutes will be going on in the introduction part. So the interviewer will introduce himself and you will also introduce yourself. We'll talk about the company. So this will go off easily on the introduction part, the first 10 minutes. So you'll be left with 50 minutes of your interview time. Mostly you will get some extra time. There is not a hard stop. 5-10 minutes here and there will definitely work out. So at this point over here, you will get a problem statement. Now, once you get this problem statement, don't rush yourself, take your time, talk to the interviewer. Again, make it sound like a discussion. So that is another important point that I want to focus on. So first, ask all the clarifying questions. So the first thing that I will recommend over here is to ask clarifying question. Spend a good amount of time getting all the clarity in the requirement. The problem statement given to you will be very abstract. I will show you some example down the line in this video. But overall, the problem statement will be very abstract. So get all the clarification, ask the in-depth question to get the clear requirement that the interviewer is looking for. So that is a key over here. So spend a good amount of time. So once you get the clarity, write down the things in the app that is being shared with you. You might be shared a doc or an app or a link or a pen and a paper or a whiteboard like this, whatever it is. Put it over there so that it remains in front of your eyes when you're solving the design challenge. Okay, second is to break your requirement. So what you'll do is you have to break your requirement into functional and non-functional requirement. So from the above problem statement, come up with the functional and the non-functional requirement that you will fit inside your design, right? The third point is to come up with the estimation. So when I say estimation, there are a lot of things that need to be covered in the estimation section. First, you might check on what is the volume of requests that the interviewer is talking about. That will give you a lot of clarity that are we talking about a 10 million requests per minute or a 100 million requests per minute. Get a clarity on that same, that what is the number of requests that you are talking over here, and then each of the requests, the size of the request. So when I say size of the request, I mean there is any image or video or any big media file that is involved here or not, like an image or a video is being uploaded, or it is just a JSON payload that we are talking about. So this will give you an idea on the size or the request payload size. Why is it important? Just think about a 10 KB request that you are getting at 100 million volume, and compare it with a 100 MB request that you are getting at 10 million per minute. Which one is going to cost you more? You need to process it, right? You are just not going to dump it somewhere, right? It has to go through a lot of services. You will be doing a lot of work on these things. So just think of YouTube, right? 30,000 hours of video content is uploaded every hour. So just think about it. Your video needs to be kept in a HD version. It's going to be in a 720p, 1080p. It should be mobile ready. The thumbnail should be there, and it is being served globally, right? And you want your video to be live as soon as possible, right? So these will give you a good understanding of the kind of infrastructure that you'll be building. The next thing that you should focus is your storage. So once you get this data, you are also talking about a storage over here. The storage includes your file system storage or blob storage or whatever you say, your database storage, your cache storage. You are storing in so many places, right? And just think about a scenario over here. Let's take example of a YouTube. Just a naive example over here I am taking, right? You are uploading a video of size 100 MB. I am storing that 100 MB in a server, let's say in Mumbai. We got a flood. The data center is drowned and all the data is gone. Will you accept it? Will you accept such a service? You have put in a lot of effort to create this video. Now your video is gone. It was in only one place. So now think about how we can save this. Let's say we are in Mumbai, right? We stored this file over here, which is of 100 MB. I'm taking a very naive example. We store a copy, right? Let's say we store a copy in Delhi and we store a copy in Singapore. So what happens when a flood comes to Mumbai? Your request can still be served from Delhi. If Delhi is also gone, I can look to a nearest country, say Singapore, and I can still serve it from there, right? So what we need is redundancy or duplication of data, right? We need to duplicate our data. So take those things into consideration when you are talking about storage. So storage, volume, size, everything has a different level of complexity that needs to be discussed. So before going into the actual design, talk about all these things. This is going to show that how concerned you are and how thoughtful you are to the requirement. Apart from this, there are many things that also you need to take care of. I'm going to talk about few of them over here. The next one I'll say is security, how you are going to secure this data, right? So security is one thing. We have already talked about the resiliency part. So how resilient your system is. Your data is gone from Mumbai, Delhi, and you are still serving the data. You are not impacting your end user. So all the services that we are putting so much effort is basically to satisfy our customers or the clients, right? So always think about the customer first. It's one of the Amazon principle, but it's a principle for everybody. Think about the customer. Be obsessed with your customer, that I need to serve him something. It's not that he comes to me and I tell you, okay, 404, I did not find anything. That's not going to be an acceptable thing. And second is, what is the latency we are looking at? So how fast we can process the request. There are several ways we can expedite this. We can have a asynchronous or a synchronous flow. So read about them, about async and sync flows, having the caching, having an event driven architecture. Lot of thing can be done over here, so read about them. So these are the things that we need to look upon. So given a requirement, I have to think about what is the response time the user is looking at, whom are we serving, right? Are we generating a report? Then let's make it asynchronous. We don't need to give the report right away. We can just take the start date and end date and then generate the report and give him a download link. He can come back later, right? It will be done in seconds. That it's not urgent, right? So take those calls judiciously to understand that it needs to be completed ASAP, or I can still delay it. I can still make it a asynchronous flow, right? Talking about the storage, one thing I would like to mention that you have to come up with the right kind of storage. So I told you over here database. So database is not good enough. Now you need to figure out, you need a SQL database, you need a NoSQL database. So let's say you chose a NoSQL database. That's also not good enough. You should justify your answer why you need a NoSQL, right? It's not always that the NoSQL is a clear winner. NoSQL means not only SQL. It doesn't mean no to SQL, right? So in NoSQL also you have row storage, you have column storage, you have key value stores, you have your document store. There are so many kind of storage. Now, since you have gone for a NoSQL, you need to justify what kind of NoSQL are you talking over here, right? That need to be justified. And if you are going for a SQL also, you need to justify why you need a SQL, right? Indirectly, that means that you are tending towards the ACID properties. So understand what are the ACID properties, why it is important over here, what are the different indexes. So creating an index is not good enough. There are so many type of index that we can create. So talk about them, understand the details of the things, right? Each of the choices that we make over here need to be justified. Any question that's being asked needs to be answered, right? Again, in a NoSQL, there are so many things. You need to set up your replication, you need to have your sharding, you need to have partition your data. There are a lot of things that you should go ahead and read about it, right? So let's say we take an example of Cassandra, right? There are a lot of functionality Cassandra offers, right? It's not just about writing the data and reading the data back. There are a lot of things that you need to understand. What is consistent hashing, what is quorum. So you should be knowing all those things. Again, this consistent hashing, quorum, I took the name with respect to Cassandra, but it is not limited to Cassandra only. There are a lot of database and lot of solution that uses consistent hashing and quorum. So go ahead, read those concepts. Those concepts were adapted by Cassandra, so you need to understand them. You might need it for your normal services as well. So also read about messaging, queues, messaging, all those things plays a very important role. These days you have system like Kafka, which can act as a backbone of the entire architecture. This event-driven architecture is very much popular. Understand them, the saga pattern. There are a lot of event-driven architecture pattern that's being used in a day-to-day basis in all the solutions. So do read about them, and it's going to provide you a lot of insights. So with that, we have covered all these points over here. Once we have the estimation in place, now it's time for you to gradually progress through the actual design of the system. So go step by step, start from the client facing or from one end of the system and sequentially move to the end of the system, covering all these points that we have talked about and all the requirements, the functional and non-functional requirement that we have captured so far. So you'll be gradually going through, talking about them, putting the right component where it is needed, answer the follow-up questions in the right way, approach from the right way why you are making that choice. So when you are making a choice, make sure you talk about the pros and cons of making the selection, emphasis on them, why you are choosing a load balancer or why you are choosing a cache or why you are choosing a SQL over a NoSQL or the vice versa, whatever it is. Make sure you talk about all of them, right? So talk about the limitation. It's not that a single system can handle everything, right? So there will be bottleneck. Talk about your constraint and bottleneck. It could be dependency on an upstream or a downstream service, dependency on an API gateway or the external vendor or ACL service or authorization, authentication, whatever it could be. There could be many things. If you have identified things, talk about them. And also to talk about, I forgot to mention it over here, that you talk about your testing strategies, right? We have previously talked that we have 600, 700 services that's being deployed. There will be so many APIs, there will be so many flows, and it's not possible for us to manually go ahead and test it, right? We have unit testing in place. Apart from unit testing, in the microservices architecture, you should have a lot of other testing as well. Everything should be automated, right? Unit testing is definitely there. Apart from that, you can have an API test, you can have a container test, you can have a integration test, you can have your CI/CD pipeline wherein you have integrated everything with the CI/CD. So whenever a code is merged, a build is triggered, a particular smoke test is executed, you can have end-to-end test, load test, performance test. There are n number of testing. So keep in mind, in big tech companies, you write more test code than actual code. Your code is defended by the test code. Your test code ensures that nothing is breaking, everything is stable, and everything is working as expected, right? You might get a defect. In that case, you have to integrate that in your test suite, fix the problem, ensure that it's been taken care of, whatever is identified by the customer or the client, whoever it is, and you go ahead and write the test case for the same and then put the fix. So when you have such a complicated system and it's being deployed, you need to monitor them, you need to have the right alerting, and with each of the alert you will have a different kind of severity. And for monitoring and alerting, there are several tools, right, available out there. We have systems like Splunk, we have App Insights for Azure, we have Datadog, we have New Relic. So try and find out what they does. So it's very interesting thing what they work on. We have Prometheus. In general, to give you a small idea, you have all the services instance running maybe in let's talk about a single service which is running in EMEA region, and this is running in APAC region, and they are continuously pushing the logs into your Splunk. So you have all your logs over here. What you do is you write queries over here. So Splunk is capable of doing a lot of things, right? Not only just queries. So when a particular, say you say that when the 5xx or 500 series response exceeds 100 within a minute, you trigger a alert. So a alert will get triggered, and you can integrate this with system like PagerDuty. So what will happen is one of the person from your team or the particular team, this service where whoever owns the service will get a mobile call no matter what time it is, and you will be notified that something has gone down and you need to take the correct action. You can have different severities. You can have severity 1, 2, 3, or high, medium, low, however way you want. So these kind of mechanism is often used to identify problems. So over here, spend a little bit of time in understanding those kind of system. So this will give you a good understanding of the entire end-to-end system, and you'll have a better understanding how this entire ecosystem works, right? And now coming to this interesting part, type of question asked during an interview. So the kind of question could vary. You can get a very abstract question. You might get questions from the services that you use in your day-to-day life. So what I basically do is I use this whiteboard in order to give the interviews, system design interviews. So I will show you one of the question and how I approached. I will not go into full details. I just wanted to show you how all these things fit into the interview. So this is one of the real interview. So the problem statement given to me was pretty straightforward, that the interviewer said that he was looking for an online snakes and ladder game. That's all that was given to me. So just think over here that how abstract is this question, right? So I need to develop the backend for a snakes and ladder. That's what he told me. So the first thing I did was to break into the functional and non-functional requirement, define the rules, the flows. So I mentioned about that the game session will be of 2 to 4 players. And then I have given him the rule that a dice will be thrown in a round robin fashion between 2 to 4 players. Whoever gets a 6 or a 1 starts the move. You get extra move on 6 and 3 consecutive 6 cancels. So this was just to give him an idea that I understand what he's talking about. And I have defined some rule. Whoever reaches 100 wins. Then I did some estimation analysis that there will be 100 million games hosted every day. it should be low latency, and players could be across geos. So you might be playing with somebody who's in a different continent altogether, right? So this is where I started, and I will not take you through the whole. I'll show you some of the interesting part where the discussion went into pretty deeper mode. So over here, I talked about socket, that I'll be using socket, and I told him that I'll maintain the socket connection between all the four players, and we'll be communicating through the socket. So he told me that it's not possible that all the players will have sockets. Some are playing using some old mobile devices which does not support socket. So basically, what he wanted to test me is that how I can come up with the alternate approach. So then I talked about a long polling. So I said when player one is playing, or we are waiting for his moves, player two, three, and four is doing a long poll on the server. So they are just waiting. Once player one gives the move, we complete all the long polls, giving them the result and also notifying the next player whose move it is. So P2 will be my next player, and P1, P3, P4 it will go into the long poll again. Then it struck to my mind, what if somebody is disconnected? So immediately I told him that, okay, what I'll do is it might happen that his network connection is poor, or he's not willing to play, whatever it is. So if I don't get a response from him within 45 seconds, I am going to cancel the round and pass to the next player, right? So these are the things that's very important, and you should be proactively talking about all of those things. So then I told him if he continuously doesn't give his move for 2 times or the configured number of times, I will kick him out of the game, and the game will go on between P2, P3, and P4. And then I said if P2 also drops, P3, P4, I can still continue. If any of them drops, I'll announce the guy who's there in the game as a winner, right? Then he told me, what if I don't have a friend? So how you are going to manage that? So I created a very simple queue over here, region based queue. So I am going to take 4 players from the queue and host a game. I'll continue to do that whenever I have more than 4 players in my queue. So these are the things that you need to think through when you are designing a game. And of course, when talking about the API part, you need to tell him the different APIs that you are going to expose. So I did the same for him. I told him these are the different APIs. It was more of a discussion, so I was talking more, and he was pretty convinced. The interview went well. And you can see over here that I have a load balancer here, right? And I told that I'll be using IP hashing. So you can see the thing that I told you already, right? That you need to be detailed when you're talking about something. And why did I choose IP hashing? Because I wanted to redirect them to another load balancer, which is in Asia. If their IP is from Asia, right? If I do that, it will always land into the same load balancer. And from Asia, what I'll do is I will do a round robin over here, right? As you can see that I have multiple load balancer. It's not that I am relying on only one load balancer. EU has its own load balancer, as you can see over here. And then I created some stores, and I am storing the rule over here. And also one thing you should keep in mind, that you are playing a game over here with your friend. You are playing so many games. How often are you going to come and check the result of the game that you played last month, right? It doesn't make sense, right? So I told him that I can do an archive, or I can purge the data from the main database or the main store, so that I can save on space, right? I don't need to keep the data lifelong, right? We are storing a lot of data already, and I don't see there is any point why I should be storing all those data for a prolonged period of time. So you should talk about all those things over here, and that will be something very important for you. So let me see what else I talked about. I went ahead and defined the data store over here. This is my schema, and I chose to go ahead with the document store. And I have given him all the explanation why I'm making this choice, and the game events I was storing over here. So I have defined all the required schema. Talked about some of the caching strategies over here, as you see. There was many things that was discussed. I'm not going into that. So once you give the interview, it will vary based on the interviewer. He might be interested in some particular section of the design, so he might ask you some follow-up question based on that. So overall, keep your interview balanced. Start from the requirement, the functional and the non-functional requirement. Talk about the API, the storage, and then talk about all the components that you are going to use in the system. This is another nice interview experience I had with one of the big tech companies, wherein you're seeing the Amazon page over here, right? This is the order page. And you can see over here that this has been delivered on 31st October 2021. So I have placed the order on 23rd October, and it took 8 days almost to get it delivered, right? So he wanted me to design how can I track this package. So if you click on this track package and let's go to the updates, and you will see over here that that trace from where the package moved from one warehouse to one another warehouse, and then finally it was delivered to me and it was out for delivery. So how can you design such a requirement wherein you have to deploy everything? So you have to do it from the scratch. Let's say Amazon is there, this functionality is not there. So how you're going to build it? What are the key areas that you should be focusing on, right? So this was a pretty interesting question. I defined the users, I defined many use cases. I defined that, okay, some might not have access to the computer. They could send a SMS in order to send the update as well with their registered number. So you will, from the SMS, you can track it and put the log directly into the system. So we discussed a whole bunch of things. So here nobody's going to stop your imagination. So you can imagine whatever you could do in order to achieve this kind of functionality. So coming back to the board, wherein we have talked about the components, right? You might be asked to design a Redis cache of your own. Let's say we don't want to use the existing Redis cache. You need to implement a Redis cache. So how you're going to do it? Or you might be asked to design a rate limiter. So in that you have to understand what a rate limiter, how that component works, what are the different features, and then it's up to you how you're going to implement it. So just to give you a quick understanding what kind of discussion it went to is, let's say I have a Google Map kind of service and it exposes some APIs to me wherein you call the service with the latitude and longitude and it gives me back the country, right? So what happens is, since you are a free user, maybe you are given a limit of 100 requests per day. After that, what will happen is you will start getting 429s. Means you have already used your quota. You cannot make any requests for the day, right? But it might happen that other big companies, let's say Uber is also the client for Google Maps and they have purchased a premium license, right? So this is Uber over here, and Uber will not have a small limit like you, right? They might have a 10 million requests per day limit, right? So you can understand based on the kind of client. So you are also a client, he's also a client. Based on that, what Google Maps is doing is it's stopping your request, right? He has a different limit, you have a different limit. Let's say Ola also have a 1 million. They do not have that much volume, so they purchase the plan like this, right? So every single client, Ola is a client, Uber is a client, you individual being a client have a different limit. So how you're going to impose this, right? Or the requirement can even go complex, saying that, okay, I have this limit 100, I'm going to allow you till 120, but 120 plus I'm not going to allow you. So let's say this is my soft limit, then this is my hard limit, and this is my limit. So I am going to allow till 20% deviation over here, but I am going to take 5 seconds extra. So this latency is added, right? And this usually, let's say, used to take 2 milliseconds. And after 120, what you get is a 429, which means that your request will not be served. So you will get 429, meaning too many requests, that you have exceeded the limit and you cannot make any requests for the remaining period. It could be a day, could be an hour, could be a minute, it depends, right? So can you design a system like this? So you have to be prepared for that. Or you might be told, so this was rate limiter. You might be asked to design something like a Redis. So in that case, you have to understand how Redis work, how, again, I'll go back to that consistent hashing works. It's a very important concept over here. So you need to understand all these things in quite a lot of details. You need to understand when you are going to choose between consistency and availability. Is consistency better or availability better? The answer is both are not good, both are good. It depends on the kind of scenario that we are looking for, right? So let's talk about a scenario over here. Let's say YouTube video comment count. In this case, what do we choose? Should we go with consistency or we offer availability? Let's understand this problem statement a little more. Let's say we have 3 servers. And for a particular video, what happens is you have 1000, you have 999 comments. Let's say a new comment has been added. So it was added here and it went here and it also updated here. And for some reason, this update actually failed. So it was still at 999. So I have a user who wants to see how many comments are there in the video. He's just casually browsing. His request goes over here. He gets 1000. Another user from a different region, maybe his request goes here. He sees 999. Should I show him 999 or should I say that, okay, some error, come back later? Just think of it. Does it make sense? Is this data so crucial that we are going to tell him that, okay, I am not going to show you 999, but I am stopping you from seeing? In this case, it doesn't matter. It's a data which is eventually going to get consistent once this problem of the network resolves, right? So he is good. I can still show him 999. Nobody's going to get affected, right? So eventually it will get consistent, but it's okay. I can still show him this data. This is where I will go ahead with availability. Now think of a scenario, your Amazon pay balance. Again, we have 3 servers. Let's say this is the 3 server. Your balance is say 1000. It's 1000 everywhere. So you did a purchase over here. Your request went here and we deducted 500. This sent a request to him to deduct 500 and it was also deducted. The database balance was updated. But somehow this one fails. Now the next time the user want to check his balance and want to do a purchase, his request goes over here. So his actual balance is 500. But what he's seeing is 1000. So that means he's eligible to make a purchase for 1000. But he doesn't have that balance. So in this case, what matters for me is the consistency. But in the other case that we have seen, in this case, what matters to us is the availability. So you need to make this kind of calls judiciously to see what kind of things you want, right? Now the question is, do you need separate database to have consistency and availability? No. Let's say Cassandra. Cassandra can take care of both. So you have to understand a lot of concepts here. What is a quorum? What is a local quorum? There are a lot of Cassandra parameters that we can play with at every transaction level. So you have to build an understanding around all these things in order to solve such problems, right? So yeah, go through all of them and I'm sure you will be doing great in the coming interviews. And with that, what we'll do is we'll conclude. So with that, we'll end our video over here. I think I have covered a lot of point. I've recollected everything that I could and I think that will suffice for a good interview. So I have added some do's and don'ts over here. So the first do is get clarity on the requirement, define your functional, non-functional requirement, talk about the estimation, everything that we have discussed over here. So focus on that, try to go with the systematic approach. Talk about automating your tests, right, for your services. We cannot have manual testing. We cannot do so many API testing. There could be so many scenarios over here, right? So talk about them. It will definitely create a very good impression for you. And on the don't part, what I have done is I have added that don't be in a hurry to jump to the design, right? Design is the last thing. Talk about everything else before that. Evaluate your design choices. Make sure your interviewer is in agreement with you that you are making all the right choices. This is going to suffice the requirement, right? Then only move to the next part or the design part. And the last point is definitely both for coding and system design, don't remain silent, talk through the entire interview process, keep the interviewer engaged, make it sound more like a discussion, just as if you're sitting with your colleague trying to figure out a solution for a given problem. Don't be afraid of him. There is nothing to be afraid of him, basically. So spend some time on all these things. Do go for mock interview. If you're finding it difficult to find a partner for the mock interview, the channel is always there to help you. Do reach out to me. We can have some scheduled mock interviews wherein it will be helpful for the other viewers in the channel as well. So yeah, that's all from this video. I think I have tried to recollect everything, all the points, and definitely I'll be sharing all the links in the description below. So do let me know what you think about this video. Do give it a like. The video is stretched almost 1 hour. And do share with your friends who's preparing for the interview. You feel might be interested in such videos, help the channel to grow. And that's all from this video. Thank you. Bye bye and take care. And also all the best if you have an interview coming up. Bye bye.